Wasabi, you guys. It's time to speed integrate some integrals from UC San Diego. Alright, let's go ahead and do the first integral. That looks like... I don't want to do partial fractions, but... Here, I'll just go like this. Okay. So, here, first of all, I want u to be this. So, let's see, 8x plus 4. Oh, not 2. This would be 2x plus 1, technically. I need 2x plus 1. Oh, damn. I need 2x plus 1. Damn. Fine. 3. 2x. So multiply everything by 2. Right. So this would be plus 4. 2x plus 1 minus 3. Okay, so this is 3 halves. I need to be careful. This is du. This is 2x plus 1. So I'm dividing by 4. So it should be 3/8 over u plus 1. 2x plus 1 square plus 4. This is its own integral. It's halved. Goddamn. Okay, so 3/8 ln plus 4x plus 5 plus, let's see. Goddamn, 1/8 inverse tangent 2x plus 1 over 2. I think this would be my answer with plus c, whatever. Okay. Next one. That is just 2 inverse tangent of square root of x. Come on. There you go. X squared inverse tangent. This is just integration by parts. So this would just be inverse tangent of x squared, x cubed over 3, like that. So you have this, and then you have 1/3, then x cubed plus x minus x, half. So my answer would be like x cubed over 3 inverse tangent minus x squared over 6 plus 1 over 6 ln x squared plus 1. Something like that. Oh, something like this. Okay. Oh God. At this point, they're just playing with some shit. Okay. When you run out of integral ideas, this is what you do. Don't actually do it though. This is not okay. U is equal to square root of e to the x plus 3 over 2, right? And then I'm assuming du. This actually does become like 4 e to the x plus 3 e to the x, which is exactly what we have. So this is sine of square root of e to the x plus 3 over 2 plus c. Right. You could do it in your head, but I like to do it like this, just in case if I'm missing a constant, then I have to do you have to be careful with that. So that's why I still do u sub anyways, just to sort of check. It's just safe. That is cosine 2 ln of x. Yeah. That's all this is. It's just cosine of 2 ln of x. I should memorize this, but pretty much this is just like you pretty much just let u equal 2 ln of x, and then u over 2 e is equal to x half of e over 2 equal to dx. Oh my god, I honestly don't want to do this, but I have no choice. This is e to the u over 2 cosine of u, right? And then you just kind of do integration by parts here, right? So you do I'll integrate. So I'll derive cosine, integrate this u over 2, right? So this is like that, and this becomes 1 2 like that, because we're dividing by half. Okay, this is just 1, so we have 2 like that. Okay, so I wish I have a whiteboard. This would be like I is equal to e u half cosine of u plus 2 sine of u, and then minus 2i, right? You get, add that, this will give you 1/3, and then you should get like 1/3 of e to the u is equal to ln of x, 2 ln of x actually. Oh wow, so this is like x, and then cosine 2 ln x plus 2 sine 2 ln x. Use absolute values actually, and then you won't get penalized. Alright, cool. Oh boy. Oh no. Oh no. I'm so tired. Okay. Well, let me just screenshot this. Okay. This is 2 pi over 2. I have not taught you advanced Wally's trick. I'm so sorry, but I have not taught you advanced Wally's. So unfortunately, I'm just gonna start bashing here. Let's see, this is 1 minus c squared of cosine 6. This is equal c cubed minus c5 squared. And so this is what? c6 minus 2 c8 plus c10. So this is like 2, and then we have pi over 2. I'm just gonna factor out pi. I'm gonna factor out pi. Okay, and then we have 1, 2, 3, 4, 5, 6 minus, and then 2 times. Okay, so 2 times and then the half, which cancels out. 3, 4, 5, 6, 7, 8. This is why you need to learn Wallies, because you'll end up shit like this. And then a half, 3, 5, 7, 9. Oh my god. Okay. Oh my god. Why? Why would you? Why? So we get 15 over 8 times 6 minus 15 times 7. Well, you know what? Let me make this as 35, and then this cancels out to like 2. So that's 64 plus, and then oh god, we have this 9 here. I just don't want to do this. You can honestly leave your answer like this. Actually, that is actually allowed. So I'll simplify it a little bit. So we get 2, 8, 64. Okay, 2, 8, 64, 128, 0. Right, this became a 2 because I canceled that out, so it's just 35 times 9. I'm gonna leave my answer like this because I don't want to work that out. I genuinely do not want to work that out. Let me double check my work. If I do that correctly, right? I turned this to C cube and absorbed it. Yeah, that looks right. Okay, I think that's it. I don't want to simplify this, man. This shit nasty. I don't want to simplify that. Yeah, that's my answer. Okay, next one. There's actually a shorter way, but I forgot how to do it. I'm sorry, I forgot how to do it. I think it's like either a beta function or or probably another type of Wally's trick. That's like an advanced Wally's trick. This you just conjugate, so you just multiply top and bottom by 1 minus cosine of x, and you get like sine square at the bottom, so you should get like cosecant x minus cotangent x secant x. So that should answer cosecant x minus cotangent x plus c. I think that's the answer. Tangent cube, you take out the tangent x, and you get secant square minus 1 times tangent x. So you should get something like tangent square over 2 minus ln of secant x plus c. Right? Yeah, I believe so. This is just the dummy partial fractions that I showed you. You can factor it, x squared minus 1, x squared plus 1, and then put a dummy variable, let alpha equal x squared, do partial fractions, and then substitute it back, and you should get something like, I don't know, some inverse tangent, inverse tanh, hyperbolic, something like that. Here, let u equal inverse tangent of square root of x, and you get 2u, so it's like inverse tangent squared, square root of x. Something like that. I'm just going by fast. Oh boy. Of course they would put this in. Of course. Why am I not? Of course. Who would not want to put this in? Wow. Okay. This is pretty much n equal to 0 to 4 n plus 1 plus n? Yeah. And there's 2n plus 1. I should know this. I actually forgot. I should know this. Whenever you have a sum of 2n plus 1, I think it's like, isn't this supposed to be like k squared, right? Because it's like 1 plus 3 plus 5. Yeah, I think it's k squared. So I think this is just 16 then. I think it's 16. Alright. Oh my god! Oh wait, actually no, that's an odd number. Take out cosine of x, turn cosine 4 into 1 minus sine squared, and so let u equal sine of x, and you get 1 minus u squared, which gives you u4 minus 2u squared plus 1, and then you get u5 over 5 minus u2 2/3 u cubed plus u, and then you let u equal sine of x, substitute back in, and then you're done. This is evil. This is a nasty integral, actually. I had a similar integral like this when I computed, and I nearly died. Except that the only difference was that mine was an 8x, and I did something wrong because I was going way too fast. But yeah, I nearly died. I had 30 seconds left to fix everything, so I just quickly restarted. Try not to, like, yeah. So 2u. The derivative would be 2e to the x, 2x, which is what, u squared plus 1? Yeah, u squared plus 1. Okay, yeah, so this is just u squared plus 1 du, which is just u minus inverse tangent. Yeah, so u, so this I think this would be be the answer. Okay. Next. Of course. E to the x here, e to the x here, right? Let e to the x, let u equal e to the x. Ooh, wait a minute. Oh! This is inverse secant of e to the power of x over 2. Can I do that? Is that allowed? Wait, let me double check that. Let me see if that's allowed. Oh, that might not be allowed. But instead of e to the x, let us multiply e square root of x square root of x here, right? And then we have this. Let u equal x over 2, then du. Oh, I'm wrong. I was wrong. I forgot the constant. This would be a half x over 2. So this would be u, 2 du. Then this is 2 inverse secant of u. Okay, so don't always do everything mentally. Be very careful with constants. Constants can eliminate you a lot. Just, yeah, don't be like me. This is tanh x. Oh god. Ooh. Ooh. Do I want to do this? I'm kind of debating. I'm debating. Do I really want to do this? Ooh. I don't know. I don't know. You can either let x equal sine theta, and that'll give me like. I just want to check. I just want to check. Okay, and I get pi over 2, pi over 4. That is not cosecant. There you go. And then I get a half of cotangent negative 1, and then I get cosecant squared minus 1. And this might be the easiest way to do it. This might be the easiest way to do it. So this is cosecant squared minus, no, is it plus? I think it's plus 1. No, it's not. I'm sorry. No, it is cosecant squared minus 1. Because 1 plus cotangent squared. Right? That is how it works, right? Oh no, I don't even remember. Yeah, it's cotangent squared plus 1. So, cosecant squared minus... Okay, yes, I was right. Oh no. That's not good. I should know that by heart. Okay, so then this is a half. So this is theta over 2. This is actually plus. This would be plus. Plus 2 cotangent theta. Okay. We plug everything in now. This is... wow, everything's negative. Everything is negative. Theta over 2 cotangent square, and then plus theta over 2 plus cotangent. I am very hesitant for some reason. I feel like I don't know. I feel like I messed up something. I don't know why. So a lot of I want to make a note here. Cotangent of pi over 2. That's what? Sine. Oh, wait a minute. That's 0. That's all 0. Okay, so pi over 4. Wait a minute. Is it really 0? Oh no, yeah, it is 0. It is 0. Okay, and then pi over 4, that's just 1. Okay. Cool. So then this is just negative pi over 2, plug in pi over 2 here is pi over 4. So we get minus pi over 4. Minus, and then plug in pi over 4, we get pi over 4, pi over 8. I should probably go like this because I feel like I'm gonna fuck up. Alright, so pi over 4 minus pi over 8, plug in pi over 4 here, I get pi over 8 as well. And then 1/2. And then this is also pi over 4, these two become pi over 4. This cancels out. So I get negative 1/2? Is that my answer? I hope so. I hope so. I hope so. I hope so. I don't think I did anything wrong. I hope so. Okay, negative 1/2. I'll take it. I hope I'm right. I don't know. I genuinely don't know. I'm not very confident in my answers because everything is sus. This is inverse tangent. So this is like a half inverse tangent of e to the x over 2 plus c. This... damn. There's actually... It's not x. You can't let it equal to x, actually. There's a domain restriction. There's a domain restriction. So you have to be very careful. The best way to look at it is letting u equal what, sine of x? du I'm sorry. Du 1 minus u squared equal dx. This would be inverse, yeah, inverse sine. Right, so now we have plug in 0, that's 0, plug in pi. If you plug in pi, you also get 0, right? But then that's like, you know, there's something not right here. There's something not right here. So the reason why it can't be 0 is because I don't want to graph, because I don't want to force you to graph. So pi over 2 to pi, then we have a problem. And the reason is because if I plug in anything like, let's say 3 pi over 4, right? 3 pi over 4, right? This is equal to what? This would equal to like root 2 over 2. But then this is pi over 4. Right? So this would equal pi over 4. But pi over 4 is not equal to 3 pi over 4. So that's why there's something wrong here. And what's actually going on is, again, you don't necessarily have to graph this, but I'm just explaining to you here, pi over 2, because of this domain restriction, whatever this graph looks like, this isn't what the graph looks like. This isn't what the graphs look like. I'm just drawing an example, but it will look like this, and then it'll kind of go like symmetric. So it's actually, there's like some sort of symmetry, something like that. Be very careful. It is not equal to x. So it would be, wait a minute, if this was x though, if this was x over 2, people would guess pi squared over 2, right? But it would I think the answer is pi squared over 4. Aha, I was right. So you see how it's like symmetric at pi over 2, right? So it's symmetric here, right? And the reason is because of the inverse sign. The inverse sign has a restriction, and so that's why like it kind of sort of reflects backwards. So yeah, symmetry. Cool. So I was right. Thank goodness. Yeah, and then it's the same thing, the same concept. Okay. Oh my god. I'm so tired of this integral. I am rarely, oh my god. God damn it. Right, so you have 1 plus x4. Then I would want to do minus x squared plus x squared. Oh, okay, never mind. So then this would be like 1 plus x squared x6 plus 1. This is good because this can become x cubed squared. So what I have now is inverse tangent of x plus 1/3 of inverse tangent of x cubed. I think that's the answer. I think I'm thinking about the one where like it doesn't have x to the, so it's just 1 over 1 plus x to the power of 6. That one's annoying. That one's a pain. Yeah. Oh boy. Oh no. I gotta use residue theorem. No, you don't. My goodness, people. No, you don't. You do not need to use residue theorem for this. So we have 0 to infinity x squared. I mean, if you want to show off, I mean, go ahead, use residue theorem, you know. Shit, I wish I learned how to use residue theorem. Damn. Anyways, so this is, I just usually do square technique. So I'll go have this, half, 2, I was thinking about doing backhanded symmetry. Oh shit! I can do backhanded symmetry! What the fuck? Oh shit! Yo, Let me show you the backhanded symmetry. Okay, hold on. Let's... Oh shit, I didn't even think about that. Okay, wait. So x, so it's dx, and we have x squared, 1 over x squared, and then now they're all even, so I'm gonna do a backhanded symmetry. So that's half, like that. Alright, so now we have the backhanded symmetry. I'm gonna complete the square like this. Let's do... I need minus. I need in terms of x minus 1 over x. I think some of you guys might know where this is going, right? Square plus 2. Awesome! So now we can use Glasser's-Masters theorem. So Glasser's-Masters theorem, this is now equal to dx x squared plus 2. Awesome! And now this is just, what? 2 root 2 inverse tangent of x over root 2 from infinity to negative infinity, right? Okay, so this is, let's see, pi over 2, so it's pi, so I think this whole thing is just pi over 2 root 2. Awesome! I didn't think I would be able to use backhanded symmetry. Hell yeah! It's very rare to use backhanded symmetry. You mainly use it for either ninja substitution or for mostly like Glasser's-Masters theorem. But wow. Okay. Square technique into a backhanded symmetry Glasser's-Masters. Wow. I am satisfied with this integral. Okay. Yeah, you don't need Vesu theorem. This is just pretty much the same integral that I just solved, except that it'll be like 1 over 6 inverse tangent of x cubed. This... What? Oh, no, this is a reverse quotient rule. I think this is like x over ln of x? I think that's what it is. X over ln of x plus c. That is just integration by parts. You derive ln of x. Integrate 1 over square root of x. This integral, okay, actually when I first computed in integration bee, during high school, I lost at semifinals because of this integral. I accidentally did deriving ln of x and integrated square root of x, but you're supposed to integrate 1 over square root of x when you do integration by parts. And so when I realized that, and I'm like, shit, I integrated the wrong integral. And then when I look at the timer, I only had like 10 seconds left. And I was like, fuck, and I could not recover. Yeah, so I learned my lesson to do not go fast. This would be 2 times inverse sine of square root of x, I think. This, oh my god. Oh, I need to take a look at this. Oh, psh, no. The reason why I don't like this, alright, we have this, and then -1, and then you end up with this. Right? So this is, oh, good grief. This is no bueno. I think this is like, if I were to go fast, like if I was going head to head, I would have to bash. Like I wouldn't try wasting time thinking up anything. I'd just start bashing at this point. Let u equal square root of e to the x minus 1. Right, du is equal to 2u u squared plus 1, right? And then you just start bashing. You start bashing at this point. So 2u squared plus 1. So you get 2x e to the x minus 1 minus 4, right? And then you get e to the x minus 1. This would be u minus inverse tangent of square root of e to the x minus 1. Right, and then I would just bam, answer. Right? If I were to go head to head, oh my god. So if I were to go head to head, that's pretty much how I would do it. I wouldn't waste any time trying to figure something out. But yeah, that's what I would do. I'd start bashing before some other opponent gets to it. This I really hate. I hate it when people put this integral. I absolutely, whoever thought this was a great idea to put a textbook problem, you are a goddamn menace. You're a menace for putting this. This is torture. So what I would do is I'd derive this negative cosine, and then x e to the x minus e to the x, right? And then I go like this again. Well, actually, sine, yeah. And then e to the x minus 2e to the x, right? Okay. So I have e to the x, I have sine of x minus 1 minus cosine of x minus 2, right? And then you do the integral. This is minus I plus the integral of 2e to the x sine of x, in which you should memorize 2y. Again, I wouldn't rewrite all of this. I'd have like my eraser in my left hand, right? And then I'd go like divide everything by 2, right? I divide everything by 2. Okay, this is a half. This is gone, and so the integral of e to the x sine of x, this will give me plus e to the x half of sine of x minus cosine x. Right? Hey, if they give you an ugly problem, you give them an ugly answer, okay? That is on them. Alright? If they ever give you an ugly problem, you give them an ugly answer. Okay? They know better to not put something like this on an integration bee. They have what's coming. Okay. I probably did that integral wrong. Oh boy. Ooh. So this 0 to x square root of 1 minus x minus 1 square, right? And then if I let u equal x minus 1, I get negative 1 to 1, and then x is equal to u plus 1. 1 minus u squared du. Oh, never mind. It's not as bad as I thought. So here this is 0, right? And then here this is like pi over 2. Okay. So symmetry, odd function, and then area of a partial circle. Okay. That wasn't as bad as I thought. I thought it was going to be some sort of like an Euler trap or something like that. But no, that actually worked out, unless I did something wrong. But I hope not, because this is a very satisfying integral. Cool. Ew. Ew. Okay. So we have the integral of literally x plus 3 squared plus 1. That's literally what we have. And if I let u equal x plus 3, right, then I get u minus 3, u squared plus 1 du. Oh shit! You know what? Never mind. I'll take it. So now this is half of ln of u squared, which is like x plus 3 squared plus 1. And then minus inverse tangent of u, which is x plus 3. Wow, that worked out a lot nicer than I thought. That actually worked out a lot nicer than I thought. Wow. Okay. Yo, I don't feel like doing Weierstrass. I don't feel like doing Weierstrass. Here, let me do a quick check. If I go like 2 tangent x. Oh, but then I'll end up like this. Okay. Damn. Secant square. If I let u equal tangent x, then I get du 2u plus 3 u squared plus 1. That's nasty. Alright, Weierstrass it is. Okay, I guess we're doing Weierstrass. Weierstrass it is. Let u equal tangent of x over 2, and then we get, we can actually 1 minus u squared. The 1 plus u squared gets cancelled out. So this 2 du 1 plus u squared. So 1 minus u squared, and then we have 2 of 2u plus 3 1 minus u squared. Oh god. Ah! Disgusting. Disgusting beast. 4u plus 3 minus 3u squared. Ew, but then I have 1 plus u squared. Why would you do this? Why would you do this? This is disgusting. What is wrong with people sometimes? Oh god. Oh god. No. This is even worse than what I had. Alright. Alright, never mind. Screw Weierstrass. We're doing it JEE Main style. Okay. Please don't, I don't recommend, if you're a beginner intermediate, please don't do what I'm about to do. This is like very advanced stuff. Okay, so I need 2 sine plus 3c. Do not copy what I'm about to do. This is very advanced stuff. And then I need, if I want to derive this would be 2 cosine minus 3 sine. So you would have to do like, so the JEE Main thing, okay. The reason why I don't recommend this method is because the JEE Main trick to this is you need to find alpha plus beta, where this whole thing equals to cosine x, or pretty much c, right? But I don't know. I don't know. If I let alpha equal to 3, right, because I want to cancel out sine. So if I let this be 2, now if I let this be 3, let's see, 9 cosine plus 4 cosine will give me 13. Oh shit, is all I had to do? Oh shit! Okay, well then, 1 over 13. Then I get 3. So I get 3. Okay, so this is 3. Then plus, and then 2 over u du. Oh shit! I just did JEE Main. Okay. Then Again, I don't recommend doing this. If you're a beginner or intermediate, I don't recommend doing this. This is such a bad habit for you to do in integration B. But this is 3 over 13. This is just x. Yeah. And then this is like dx, and this is its own integral. Okay. So 3 over 13x plus 2 ln of 2 sine of x plus 3 cosine of x plus c. Holy shit. That's fucking torture. Holy mackerel. Oh my god, I didn't think I would ever have to pull out that weapon in my life. Okay. Next. Oh my, wait a minute, I just realized. If I divide everything by root 2... Oh no, I lied. Never mind. Okay. X squared over x, you just factor it out, and then you could technically do the caveman trick that I taught you. Yeah. Oh my god! You know what? I want to do something dangerous. Let's do something dangerous, shall we? Let's say I don't want to do trig sub, right? Because I don't feel like it. I don't feel like doing trig sub because this is like negative x squared something something something, and then you have to do like some constant minus whatever squared. Yeah. So let's do something dangerous. Let's do the second kind of Euler substitution. Now, again, do not do this in integration B, it's a bad habit. Let's take any root. Let's do, what should I take? Let's take, I feel like 5 minus x might make it nicer, but I feel like I might fuck up the negative. But you know what, let's take it. And let this equal x minus 3, 5 minus x. Right. So technically what I'm doing is I'm letting u equal x minus 3 over 5 minus x. That's literally what I'm doing. But yeah, so taking one of the roots, you can do this or let u equal x minus 3. Both would work. That's how second kind Euler sub does. Alright, now the reason why I don't like doing Euler sub and that I don't recommend it for training is because you have to literally freaking hurry your ass up and find du. So in this case I have 5 minus x squared, x minus 3, 5 minus x, this cancels out, right? Okay. And then I have u squared equal to x minus 3, 5 minus x. Oh god. And then you have to do, but you don't wanna, you know, you just don't wanna derive this, right? 2u du. Again, don't do this. Please don't do this. 5 minus x squared. And then this is just 1. 5 minus x minus, and x minus 3, just negative 1. Okay. So we have our dx, but then this would be, how would you put this in terms of u? Right? You see the problem with Euler sub? Like, this is why I do not recommend it. Otherwise, you have to memorize the du thing from Wikipedia, and it's like, it's nasty. It's very nasty. Wait a minute, this is just, this cancels out. 2, 5 minus x squared? Wait, but u is equal... Wait, 5... 2... Ooh... u square equals x minus 3. 5 minus x. Square this. Huh? What? Oh no, what I got myself into. What did I get myself into? Oh no, don't do this. You know what? Don't do Euler. This was a mistake. Don't do Euler sub at all. This was a mistake. This was all a mistake. Wow. Trig sub. I guess we're doing trig sub. Okay, so this is 5x plus 8x. This is minus 15. Right. Okay, so we just need minus 1 plus 1. 1 minus x minus 4 square. I'm a dumbass. That's all this was. I'm so fucking done. I did all that fucking work to realize this was just inverse sine of x minus 4 plus c. Again, I do not recommend that you do Euler substitution because it is a bad habit. Okay. Wow. I really I really overestimated this. Oh, beautiful. A JEE Main integral. Thanks, goddamn freaking Poseidon ass university. I don't think that's their mascot. I might be wrong. But divide everything by tangent no, sorry. Multiply top and bottom by tangent x, I get tangent square plus 1 plus, and then this is, let's see, secant x tangent x plus, and then s times c times 1 of s, so secant x, and then this is secant square. What are they planning? This is very suspicious. What the hell are they planning? What is this? Secant square plus secant x tangent x plus secant x. What is this? What is this sorcery? What the hell? No, I'm actually serious. What is this? Wait, okay, that's odd. Huh. Okay. Now I'm really curious what this is now. This is... Looks like we gotta do Weierstrass. Motherfucking Weierstrass. But this time I promise it'll be a lot it'll be nicer. It'll be a lot nicer Weierstrass, I promise. So maybe this isn't nice at all. Oh shit, wait a minute. Wait. I saw that 2u. I see that 2u. There's 2u. And there's minus 2u squared, right? But then I could do u squared plus 1 minus... Oh, but then I don't want to do this. I don't want to do this. I don't want to do this. This shit nasty. There's no balance. We already did like one substitution. We don't need to do another. Oh my god. Well, fuck. We're already here. You might as well. Shit. So we have 1 plus u squared. We have minus 2 inverse tangent. And now we have plus 2. And now we have to let u equal tangent theta, in which we get secant squared here. Right? But then we have motherfucking cosine square. And this motherfucking shit has to be... well, I can actually take into 2. I can take in 2, absorb 2, and this would just become 1 plus... This would just be 1 plus cosine 2 theta? D theta? And we got motherfucking theta plus half of sine 2 theta? That looks right, yeah. Oh my god. And then we have to freaking inverse tangent of u, which is x over 2. Oh wow. I'm just gonna dive right in. I'm just gonna dive right in. X over 2. So theta is equal to x over 2. X over 2. X? And then plug in u back in, right? You just plug in u. That's like what? Minus cosine square x over 2 minus x plus x over 2. Hold the fuck. Is that real? Is this really the answer? What? Wait, hold on. Wait, no. Excuse me? Wait a second. Hold on. Wait, let me really simplify this answer. Excuse you. Hold on. Wait, this cosine square, this is a half plus a half of cosine x. And then we have minus x over 2. What? This gets absorbed. But you're telling me that this whole answer was just this? What the fuck? How? How? I don't know. This is... I don't know. JEE Main is... No. No. Oh, wow! Wow! Another... You know what? How about this? Screw your techniques. Here, you know what? I'm gonna go Harvard MIT style. Multiply 1 minus sine of x. I don't know why I'm writing it like that. Plus c. Right? And then I get s minus s plus c here. This is 1 minus, so the bottom will become 1 square minus s plus c square, which is 1 minus 1 plus sine 2x, right? And then this would be like negative 2sc, right? And then here, this top part is like s minus s square minus sc all over negative 2sc. Okay, and so now we have this integral of negative half of, let's see, secant x, and then minus, oh, this would be plus a half of s, tangent x, and then we have plus half. But bam, look at that. Look at that. This is all a half of x plus ln of secant x minus ln of secant x plus tangent x. I am done. Bam. Screw your techniques, JEE Main. Okay. Oh god. That's... Alright, how many integrals are there? Ah! Oh god! What the fuck? Why? Why would you? Why? Why would you do this? Why would you? Why would you? Why would you give this to someone so poor? To some why? Huh? Okay, hold on. Actually, I want to tackle this. I actually want to tackle this. Do you actually do integration by parts for this one? Because if I go like, if I do integration by parts, right? If I purposely do integration by parts, and this would be x5, this becomes, if I derive it, and then here I get 10, right? But then I get -1 here, right? Oh, yo, okay, I fucking caught it. Oh my god, I didn't think this would work. So this is a half. x4 1 is 10. I need a 5 here, so this would be okay. So this would be wait, 5. Yeah. 1/10 inverse tangent of x to the power of 5 minus 10 x5 1 plus x to the power of 10. Ah, I gotcha. Wow. I didn't think I would solve that. Unless I did something wrong, then I'm sad. But I think this is the answer. That's very hard to see. That's very hard to see. Oh, and that's it. I would rate this as like an intermediate level. This is not beginner at all. Because there were some techniques that I actually had to yeah, it was like very I would rate this as intermediate level. Yeah. Holy Jesus.